Hi all, hope studying's going well. We're going to take a quick look at problem 3, equation solver. So if we look at the problem description, we see that we will be getting an equation represented as a list, and we want to compute a final value from left to right. So if we want to look at an example in the docs test, we have this list here, 1 add 2 sub 3. So if we look at the translated version, to compute this algebraically, we would first compute 1 plus 2. So let's take a look at our skeleton. This seems kind of like a base case since it seems like a simple return. So let's assume that our answer is going to be this grouped operation here. So if we number our items, we see that the operator is at index 1 and our arguments are at 0 and 2. So let's go ahead and write this like a function call. So first we take out the operator and apply it to elements at 0 and 2. And this would look something like add 1, 2. So if we look at our example again, the resulting the result would just look like 3, and then we want to subtract 3 from it. So this looks like we still have more work to do, and it'll be a recursive call. So that is probably what our return statement is. So we want to combine our answer with the rest of the list, which will look something like solve equation called on our answer, and then that concatenated with the rest of our list, which begins at index 3. So now let's look at our base case. So given our example 3 minus 3, once we compute the answer from that, we will be left with 0. And then in our return, we will make a call to solve equation on 0. And then what happens? Well, we see that we only have our resulting value. So all we want to do is return it. Now, how do we know we have reached the end of the list? We see that there's only one item. So we just need to check that the length of the equation list is 1, which will look like this. And that is the solution to our problem.